Good afternoon, Anurag Tripathi, Aditi Karkade, Nirmai Sable, Sanvi Boyer, Samruddhi Gaurkar, Anushka Burane, Rishika Borakunda, Riya Singh, Narayan Pandey, Jayant, Vaishali, Santosh, Venkatesh, Ishan. Is it visible properly? Is it visible? You answer. Or it is blurred? Is it visible? What answer? Is it blurred or visible? If it is visible, write down visible there. If it is blurred, write down blurred. Okay, visible. So we already started the lesson light. Okay, so depending on what we studied yesterday, I am going to ask you question. Question first, that is, what are luminous objects? What are luminous objects? What are luminous objects? Yesterday I told you, luminous object. What are luminous objects? You answer. You answer. What are luminous objects? Elias wrote an object that has its own shine and brightness. It is lustrous. Metals are lustrous. That is different. What are luminous objects? Yes, Elias, try to write. You want to write something, you wrote something. Okay. What are luminous objects? You answer. Ha. Jayant have given correct answer. Object that give out their own light. Okay. Such objects they are called luminous object. Elias wrote object that has its own shine, like metals are lustrous. They shine and that is different, isn't it? Here luminous means object that give out their own light. Very good. Then give me some example of luminous object. Give me some example of luminous object. Give me some example of luminous object. Very good. Janvi gave very correct answer. Sun. Very good. Bulb. Okay. Janvi gave sun, bulb. Janvi is only giving correct answer. Stars. Vasuki gave stars. Then, okay, sun, stars, bulb, tube light. Ishan gave tube light. Okay. Example: sun, stars, bulb, tube light. Okay. Then yesterday we studied about non-luminous object. What are non-luminous objects? What are non-luminous objects? You answer. What are non-luminous objects? What are non-luminous objects? Yesterday we studied. What are non-luminous objects? Yes, they don't have their own light. Okay, very. What Elias written, the object which do not have their own light. Okay, they do not give out their own light. Okay, they reflect the light which is falling on them. Okay, just like we throw the ball jumps, the ball bounces. Yesterday you gave me many answers. The ball comes back. Okay, so we will find light also when fall on this different non-luminous object, it bounces. That is called reflection. Okay, we see this non-luminous object due to reflection of light. Example of non-luminous object. Yesterday we studied what are example of non-luminous object. Moon. moon. Santosh gave correct answer. Tree. Elijah gave correct answer. Moon. Very good, beta. Moon, tree. These are the example of non-luminous object. This we studied yesterday. Okay. Then yesterday we studied about transparent, translucent, and opaque object. What are transparent objects? What are transparent objects? Transparent objects. What are transparent objects? Give definition. Yes. What are transparent objects? Example, Abhishek Singh gave very correct example, air and water, and Shardul gave very correct definition through which light passes, through which we can see very clearly. Elias gave correct answer. Very good. Example, air, water. Okay. Then what are translucent objects? Translucent objects. What are translucent objects? What are translucent objects? Bidwai gave very correct examples. Butter paper, very good beta. And Kalapati gave correct example for transparent object, glasses. And here Bidwai gave correct example, butter paper. Write down the definition also. Object which allow only a part of light to pass through it. Shardul gave very correct definition. Only part of light to pass through it. Butter paper example, oil paper. Trupti Vasare gave, Aditi Karkade gave example, oil paper. Abhishek gave butter paper. Then Gandhi Bendakar gave example, butter paper. So oil paper, wax paper. Wax paper, all these are there. Yesterday we studied about opaque object. What are opaque objects? Write down definition. Opaque objects. Opaque objects. Objects. Opaque object. Trupti Vasare wrote correct definition for translucent, that is object which allow only part of light to pass through it. Elias, things which does not, things through which light does not pass. Very good. Elias gave very correct answer. The object that doesn't allow the light to pass through. Tripathi gave correct answer. Shardul gave correct answer. Very good. The example, all of you are giving very correct example. Book, wall, brick. Example, book, wall, brick. Okay, this we studied yesterday. Okay, then yesterday we also studied about the property of the light. What do we call the property of the light? Property of light. What is the property of light? That light travels in a straight line. Light travels in a straight line. What do we call that? Yesterday we studied. In a straight line. Light travels in a straight line. Yesterday we studied this. Light travels in a straight line. Yesterday we studied the property. What do we call that property of light? It means the light travels in a straight line. Light travels in a straight line. Yesterday I told you that. Nobody is giving answer. What I wrote on the green board yesterday while giving the example of pipe and candle. That is known as rectilinear propagation of light. You forgot that. Okay, that is called rectilinear propagation of light. Rectilinear propagation of light. So the property of light, that it always travel in a straight line. That is called rectilinear propagation of light. Yesterday I wrote it on green board. Nobody gave me this answer. Okay, now yesterday we have done one experiment. Tell me what experiment we have done? What experiment we have done? What experiment we have done to prove that light travels in a straight line? What we have done? Don't write rainbow there. I did not ask you anything about rainbow. What experiment we have done yesterday regarding light travels in a straight line, rectilinear propagation of light. We have done one experiment yesterday. What is that? Yesterday I brought pipe. Okay, but instead of doing in front of you, I hope that doing means we understand better than. Yes, very good. Aditi Karkade, if we bend the pipe, we cannot see the flame properly. First, what Elias wrote, first it is a candle, we have to take candle, lit the candle, then look into the straight pipe, we can see that candle, and to curved pipe, we cannot see. Very good, Elias. Elias gave very correct answer. Yesterday we have done activity that we took one candle, we burned the candle, and we took one straight pipe. When we see through the straight pipe, we can see this candle. But when we see through the bent pipe, we cannot see the candle. Okay, why? Because light travels in a straight line. That is called rectilinear propagation of light. Till this we have studied yesterday. Now today one more activity is there which proves that light travels in a straight line that you have to do at home. Okay, what you have to do? You take three cardboards like this. Okay, and make hole in the center. Okay, three cardboards you take and make hole in the center. Of every cardboard you have to make hole in the center, and then you have to take one candle and you have to see through it. For example, suppose you took one board, you made one hole in the center here. Okay, like that you have to take three cardboards and make hole in the center. You have to place exactly that the center of all the three cardboards, what they will be in straight line. Okay, so if you want to see the candle through this, you can see the candle. But if you do not place it properly, then what will happen? Then we will find that you can't see the candle. This is one, this is second board, and this is the third board. In the center, you have to make hole. Here is your candle and the flame. Now all these centers are in a straight line. So light will pass through the straight line, and here you are seeing through your eyes. Okay, so what we will find? You can see this flame. But now if you in the center, these three all poles are in the center, are such that these poles they are in a straight line. So you can see this candle very easily, very properly, because light travels in a straight line, and you can see this candle. Okay, but if you move this board, now it is not in center, suppose it is not in center, what will happen? Suppose it comes somewhere here. Then this light which is passing through it, it will come here and it will block here. Light doesn't know to bend and to go. Okay, so light always travel in the straight line. Now you can't see this because light is blocked by this board. It is blocked by this board. It will not pass through this. It will not bend and will pass through this board. Okay. So this experiment also it proves that light travels in a straight line. Three boards of exactly same dimension you have to take. Make hole. Suppose this is first board. This is another board. Okay. Then make hole in the center. First board. Second board, make hole in the center. Take third board. Place exactly that the centers are in straight line. Then see the candle from one side. When they are in the straight line, you can see the candle because light travels in the straight line. It will pass through these three holes. But when you move this one hole away from this straight line, which they were making earlier, then light will come and it will get blocked by the board. Okay, it will not bend. But instead of that, if you take another example, suppose this is the door, this is the wall. Now here, a man is standing here. A. Now I can see that. Suppose Anunay is standing here. I can see Anunay from here. But here is wall and suppose Santosh is standing here somewhere. Now here light is falling on Anunay. It gets reflected and I am standing here. So I can go inside my eyes and I can see Anunay. Okay, light is falling on the Anunay and gets bound. But here also light is falling on Santosh and but here is the wall. So it gets blocked by this wall. Okay, it cannot bend here, bend and it will not come from this door. Okay, so light always it travels in a straight line. It will not bend. That is called rectilinear propagation of light. Okay. Like that, we will find many examples are there. Now, shadow. What is this shadow? Suppose there is a source of light and it is blocked by some opaque object. For example, now you know that this tube light is the source of light. And this book it is opaque object. When the light is coming from this source of light, it is blocked by this opaque object. We will find dark patch on whatever surface behind this opaque object, opposite to the source of light. That is called shadow, isn't it? You know that if you take torch, take ball. Now just switch on the torch. You will find the light rays. They are coming. But if you keep ball in between, these light rays are blocked by the ball, and we will find that on the opposite side, whatever it may be, some surface is there, isn't it? On that surface, the black patch exactly same as that of the object, showing the shape of the object, will be formed. That is called shadow. Okay. For example, this is the duster. This is source of light. Now shadow of the duster is formed on this beanboard. Because here the light rays are coming and it is blocked by this duster, and we will find the dark patch is formed on this beanboard, that is shadow. Okay. For example, my hand is there. This light is coming from the source of light. I keep my hand like this. So what we find, the hand will block the rays of the light coming, and dark patch is formed on this main board, that is shadow. Okay. Now I am standing here. Some rays are coming from the door. It is blocked by my body, and dark patch is formed here on the wall just opposite behind me, isn't it? That is shadow. So you have seen your shadow many times. You know that it is dark patch formed behind the object opposite to the source of the object when the object blocks the source of the rays of light. Okay. For example, you know that you take one stick, fix it on the ground, and observe the position of this stick different times. You know that shadow of that stick will be formed, isn't it? Now we will find in the morning 7 a.m. you will find that the shadow will be like this. Will come. Then 10 a.m. Then 12 noon. Okay. Then 2 p.m. 5 p.m. Now this shadow which is formed, it is depending on the position of the sun. At the 12 noon, here sun's position will be there. Okay. Then at the 2 p.m. here somewhere, so we will find it will block the light and the shadow will form here. Then at the 5 p.m. it will somewhere here, so it will block the this and it will form the shadow here. Then here in the morning we will find 7 a.m. and 10 a.m. Okay, so we will find you have to do this experiment. You have to do it. I have done this. You also do it. Very interesting experiment. Stick one, fix one stick on the ground, and you will find that the length of the shadow changes as the position of the sun changes. You know that when the position of the sun is here, the shadow will be formed opposite to the source of the light here at the back side of the object. Now when it will form here, and the length of the shadow, it is depending on the angle. Depending on the angle made by object with source of light. Now here we will find 90-degree angle is there during afternoon, 12 noon. At that time, we will find the shadow is shortest. But we will find as the angle increases, the shadow also, the length of the shadow also increases. Now here we will find it is making about 45 degree. Then here again it is making more angle. So as the angle increases, we will find the shadow also increases. This actually you have to do outside at the home or in outside. So if we see from right from the morning, I have done it. If you see do it properly, you can understand properly. Okay. So this activity you have to do. This activity is very interesting. This shows that as the angle between the object and the source of the light increases, the length of the shadow increases. Okay, when the angle is less, the length will be smaller, isn't it? As the angle will be more, the length will be bigger. Okay, it will log. This you have to do actually, then it will become more clear. So I request you to do this activity. You would have done this. Then suppose here is the point source of light. You take torch. Take hole here. Take one ball here. Now what will happen from this point source of light rays will be blocked, and here we will find shadow will be formed. Now this shadow, this is ball, this is shadow, this is screen. This activity also we have to do. This is torch. So what we will find when this shadow is formed, if you will take the screen away, if you will take the screen away from this torch, we will find the shadow will increase. Means here object and here source of light. Source of light, object, and here screen is there. Now this shadow is forming on the screen, but if you take the screen away, the shadow will also increase. Now if you keep the screen here, shadow will be smaller. But as you take it away, here it will become bigger and bigger. So always remember that as the distance between the screen and the opaque object increases, we will find the shadow also become bigger and bigger. Shadow becomes bigger and bigger as the screen increases. What happened here? Video is buffering. Okay, one more thing is there, that is the shadow on the screen. If you increase the, suppose this is torch and we will find here is the source of this is the source of light, and here is the opaque object. Now if you increase the distance between this opaque object and the source of light, what will happen? What will happen to the shadow? Shadow will become small or big. Yes, shadow become small or big. The shadow becomes smaller. If this distance will increase, then shadow it will become smaller. Okay, one by one you tell me. Suppose this is the source of light. Okay, here is the opaque object. Now here is the screen. Now suppose the screen is at 10 centimeter or 20 centimeter. After that you put the screen at 40 centimeter. Here. Now where the shadow of this object, opaque object will become big. Yes, where the shadow of this opaque object will be bigger at the position A or at the position B. At the position A or at the position B. Janvi Bhandarkar gave correct answer. It will bigger at the position B at the 40 centimeter. Why? Because as the distance between the screen and the opaque object increases, the size of the shadow also increases. Okay. So always remember from this that as the distance between screen and opaque object increases, we will find the shadow becomes larger and larger. It becomes larger and larger. Okay. Then suppose you take the source of light, then here is the opaque object, and here is the screen. Now you increase the distance between opaque object and the source of light. What will happen to the shadow? If you increase the distance between the opaque object and source of light, what will happen to the shadow? It will become bigger or smaller? It will become bigger or smaller? It will become bigger or smaller? If you increase the distance between source of light and opaque objects, what will be? It will become bigger. Wrong. Bigger it is wrong. It will become smaller. If you increase the distance between source of light and opaque object, then the shadow will become smaller. It will become smaller. Okay. And if you increase, here we will find the distance between the opaque object and screen. Opaque object and screen, this distance if you increase, what will happen to the shadow? Shadow will also become bigger. Okay, at that time you will find shadow will become bigger, but if you increase the distance between the source and the opaque object, we will find the shadow will decrease. The shadow will decrease. Okay. So today we studied about shadow. Thank you very much. I will stop here.